You know, over the past couple of years, it really feels like something fundamental has just shifted. Artificial intelligence went from this far-off futuristic idea to something that's right there on your phone, and it feels like it happened overnight. So let's dive into this intelligence explosion and really unpack the twin revolutions in software and silicon that made all of this possible.
For a lot of us, the starting gun really fired in November 2022, right? That's when ChatGPT launched. And the reaction from the public was, well, it was unlike anything we had ever seen before. Just look at this graph. It became the fastest application in history to hit 1 million users. It took just 5 days. To put that in perspective, it took Netflix 3.5 years to do the same thing. This wasn't just another app. It was a genuine cultural moment.
And that's got to make you wonder, right? This tech has been in the works for decades, so why this sudden massive leap in what it can do right now? Was it some single breakthrough? A lucky accident? Well, the real answer is a little more complex, and honestly, a lot more interesting.
Turns out, it wasn't just one thing, but two things working together perfectly. What we're seeing is this incredibly powerful, self-reinforcing feedback loop. You can think of it like an intelligence flywheel between software algorithms and the silicon hardware they run on. A software breakthrough created this huge demand for more computing power, and that demand sparked a revolution in hardware. Let's break down exactly how this powerful cycle works.
Okay, so first we have to rewind a bit and look at the software problem. Before we could ever get something like ChatGPT, AI researchers had to smash through a major fundamental bottleneck.
So before 2017, language AI was kind of stuck in the slow lane. The main models at the time, things like recurrent neural networks or RNNs and LSTMs, had to process language sequentially, literally, one word at a time. And this gave them two massive headaches. First, it was painfully slow, and second, it was really bad with context. By the time the model got to the end of a long sentence, it had kind of forgotten what the beginning was about.
And then, a landmark paper in 2017 called Attention is All You Need changed absolutely everything. It introduced what's called the transformer architecture. Now, what's so cool about this slide is you can see the after picture. Instead of that slow one word at a time line, the transformer could look at all the words in a sentence at the exact same time. This core idea, called self-attention, let every word connect to every other word, and it solved both the speed problem and the context problem in one single brilliant move.
So this software breakthrough was incredible, right? But it also created a completely new kind of problem. You see, the transformer's real superpower was its ability to scale, and that unleashed this just ferocious appetite for more and more computation.
Unlike the older models that would just kind of break if you tried to make them bigger, transformers just got smarter and smarter the bigger you made them. This kicked off a mad dash to build bigger and bigger models. And this graph, this shows the result. It's a true explosion in model size, going from about 100 million parameters in 2018 to over 1 trillion by 2023. That is a 10,000-fold increase in just 5 years.
And this led to maybe the most surprising discovery of them all. At a certain point, sheer quantity turned into a new kind of quality. These giant models started developing what are called emergent capabilities, skills that nobody ever explicitly taught them. All of a sudden, they could write poetry, they could generate computer code, they could even do basic logic, all just from learning the patterns in text.
But this scaling race created a bottomless pit of a need for computation. Training a model like GPT-3 cost tens of millions of dollars. And the general-purpose graphics cards, the GPUs, that had powered the early days of AI just couldn't keep up. The software revolution had slammed right into a hard physical hardware wall. Progress was actually in danger of grinding to a halt.
And that is when the other half of our flywheel roared to life. To break through that wall, we needed a second revolution. But this time, it had to happen in the silicon chips themselves.
Okay, so on the left, you've got your standard GPU. Think of it like a Swiss Army knife. It's pretty good at a lot of different things. But on the right, that's the new breed, a specialized AI accelerator. Look at that massive block right in the middle. They basically ripped out all the general-purpose parts and replaced them with these enormous matrix math units, designed to do one thing, the core math of AI, with just unbelievable speed and efficiency.
And the king of this new breed is NVIDIA's H100. This single chip is an absolute monster of engineering. It packs around 80 times billion transistors, and its special tensor cores are specifically optimized to speed up the math used in the transformer models we were just talking about. It's a perfect marriage of the algorithm and the architecture.
And it wasn't just NVIDIA either.
This huge market opportunity kicked off what you could call a Cambrian explosion in specialized hardware. All of a sudden, you had companies like Cerebras, Sambanova, Intel, AMD, all jumping into the game, creating this really diverse ecosystem of chips, each with their own unique spin on how to accelerate AI.
So, with both the software and the hardware revolutions firing on all cylinders, the two have now merged to create an entirely new foundation for technology itself.
And you know, it's really important to realize this isn't all just happening in some giant far-off data center. There's been a parallel revolution on what's called edge AI that's been putting specialized silicon right into our hands. Chips like Apple's neural engine in your iPhone or Tesla's full self-driving computer are basically AI supercomputers that we carry around in our pockets and in our car.
And this all comes together to form what people are now calling the new stack. At the very bottom, you've got this powerful hardware layer of specialized silicon, like the H100. And sitting right on top of that is the software layer of these massive foundation models, like GPT-4. And the result is a whole new kind of intelligence infrastructure, a set of building blocks that lets anyone build really powerful AI applications.
And believe me, this train is not slowing down. In the short term, we're going to see even tighter partnerships between the hardware designers and the software algorithm designers. But looking a little further out, researchers are exploring some really wild ideas, like neuromorphic chips, inspired by the human brain, and even trying to harness the bizarre world of quantum computing for AI.
Think about this for a second. The very first transistor was created back in 1947. Today, the H100 chip packs in 80 billion of them. It's an incredible journey that perfectly captures the whole point of this explainer. As the quote says, the journey to artificial general intelligence is as much a revolution in silicon as it is in software. The question now is, with this powerful flywheel spinning faster and faster, where does it take us next?